We are so honored to have Dr. Richard Johnson with us today. Professor Emeritus of Medicine at the University of Colorado, is a physician, researcher, and author whose work has reshaped how we think about chronic disease. He brings the kind of evidence that forces us to rethink our assumptions.
What is the cause of obesity and how logic can lead one astray? The great victories in medicine had been found. The first antibiotics had just been developed and that led to the first Nobel Prize. There were people thinking that it would be very easy to find the new treatments. But what happened over the next decades was the emergence of a huge epidemic that today is just viewed as normal. Obesity, which was present in only 1 in 30 adults back in 1893, is now present in 1/3 of the U.S. population. Diabetes, which was present in only 1 in 50,000 adults in 1890, now is 1 in 9. And so we're realizing that the diseases of today are new relative to the 1890s. And these diseases are basically controlling and causing all of our major health issues. So it should be a natural question. What happened between 1892 and today that could account for this? Frederick Banting, who was the discoverer of insulin and got the Nobel Prize for it, was convinced that it was refined sugar that was driving the rise in diabetes. So it turned out that by 1925 or so, the world thought that obesity and diabetes were really diseases from sugar consumption. But then something changed. And this change in viewpoint seemed quite logical. It wasn't sugar. It was just the fact we were eating more. In fact, he could show that there was a direct link of obesity with caloric intake and with inactivity. And it seemed like a simple problem. It's the law of thermodynamics. Too much energy in, too little out, and you're going to store it as fat. So I have been studying this for over 25 years. So what if we study nature to understand how obesity is beneficial and try to determine how animals regulate their weight and gain weight in nature to get a clue for what might be driving obesity in us? So it turns out that obesity can carry a survival benefit because when there's no food around, you can break down the fat to generate calories. And it's well known that many animals will purposely get fat before periods of food shortage. The classic, of course, is the hibernation. The fat is like an energy storage. And so when they burn the fat, they can provide the energy they need. It isn't just hibernation. And then the animals will eat huge amounts of fruit. The bear will eat 10,000 grapes in 24 hours. So let's talk about fructose, because that seems to be associated with this kind of triggering of weight gain that these animals do. So we use fat as a fuel, and we use carbs as a fuel, and the carbs generally get broken down to glucose, and glucose is what we use. And we measure blood glucose, and your doctor measures it on you, and you probably all know what your glucose levels tend to be. But the other main simple sugar is fructose, and that's the sugar that's present in fruit and honey. And we think of fruit as healthy, and fruit is healthy because it's got a lot of good things. But fructose is not itself healthy. And so when you eat table sugar, you're getting glucose and fructose. So we wanted to know if fructose might actually have a role in changing appetite. It was a model of overnutrition. You put an animal on sugar or fructose, and they start eating more, and they exercise less, and they gain fat. So why did they eat more? Fructose is causing leptin resistance and affecting the ability of the animal to regulate its weight. Now it will eat as much as it can. And we found that was in fact what caused weight gain. So the obvious question is, what happens if you don't let them eat more? And it turned out that after 4 months where both groups are eating the same amount of food, exactly the same amount of food, the weight is basically stable. There was a little bit of increased weight in the sugar group, which could be important over years. But look at this. Although weight didn't increase, these animals became diabetic. Every animal that got sugar became diabetic. Every animal. And what's more, they all got fatty liver, and they all got hypertensive, and they all got visceral fat, and they all got hypertriglyceridemia. And these animals were calorically restricted, actually. So even with caloric restriction, it doesn't block the metabolic effects, blood pressure, diabetes, fatty liver, heart disease. All those kinds of things are not blocked by reducing the calories. What causes the weight gain is the leptin resistance. And what causes the leptin resistance is fructose. And fructose, independently of weight gain, is driving diabetes and metabolic syndrome, fatty liver, and so forth. Here's another thing. If you make an animal leptin resistant, they'll start to crave fat. Normally, animals don't crave fat. They don't have fat taste receptors. But once you make them leptin resistant, they love that fried chicken. They love polyunsaturated fats, the seed oils. So the question is, how does it work? Once the ATP levels are full, there's no desire to eat anymore. So there isn't really any energy going to fat. But the way fructose tricks the system is it prevents us from filling up the ATP. It actually works on the mitochondria to block the production of ATP. So the ATP levels generally stay low. They're not like rock low. They're like 20% low. They're just enough to say to the organism, you don't have enough energy. Your ATP levels are low. I think this is a pretty big discovery that we made that can explain so much. And so the question is, how does the ATP get lower? Because fructose is an energy source. And over time, it will make energy. So it does make energy, but it reduces the total ATP levels in a cell. And how does it do that? Turns out there's 5 different pathways involved here that all lead to a low energy state. So it's kind of a trick. If you're obese, you have higher energy than another person, but you can't actually use it because it's trapped in your fat. Fruit, for example, is supposed to be healthy, and fruit is healthy. If you drink fruit juice, you're going to get a lot of fructose. And we showed that with people drinking apple juice. But if you eat a natural fruit, you're only eating a small amount of sugar. We found that when we gave soft drinks to animals that could not metabolize fructose, what we would call fructose knockout mice, we could completely block obesity and diabetes and block insulin resistance and all those things, fatty liver. Even though they're getting both glucose and fructose, it turns out that fructose is the dominant driver. So what's causing the brain to shrink? Well, it turns out that they get insulin resistance, mitochondrial dysfunction, low ATP, and inflammation. And when I looked at that, I said, that's what fructose does. That's exactly what fructose does. Could fructose be involved in Alzheimer's? Sugar intake is linked with a memory loss. So the higher the amount of soft drinks, the worse the memory loss. And the epidemiologic studies, the smaller the brain size by CT. You want to have a small brain? Drink 2 to 3 soft drinks a day. It's almost guaranteed. Look at the standard deviations. You don't want that, right? If you give fructose to rats, guess what happens? They have trouble getting through a maze. They get cognitive dysfunction. They get cerebral insulin resistance. They get oxidative stress and loss of energy and ATP. That's exactly what you see in early Alzheimer's. But around 2004 to 2008, we really started seeing a decrease in fructose intake. Now, remember, you can make fructose as well from breads and rice, but the amount of soft drinks, for example, started to be, going down. So why didn't obesity go down? Well, you know why? Because studies have shown that you don't just eat sugar and develop diabetes in 1 year. It takes a number of years. It takes like 10 years, maybe even up to 20 years before you really start seeing the effects of sugar when it's introduced into a society. Wanted to understand how we got her through evolution. And I began to realize that so many diseases result from, a change in the environment that leads to, what we had adapted to for survival in the past suddenly becomes really unhelpful or unhealthy in the current situation. So, today sugar is everywhere. It's very hard to link sugar with things. But when sugar was only available to a small percent of the population, you could really see how strong the drive was.